Problem 21 reads, for all positive integers a, b, and c, which of the following expressions is equivalent to a divided by c? So here, the first thing they're saying is that the values a, b, and c are all positive integers. In other words, they're to the right of 0. So numbers like 1 or 2 or 3, etc., would be able to replace the letters or the variables a, b, and c. That's important to know because it does eliminate certain things that otherwise wouldn't apply. But in this case, we can just keep it simple, look at each of these expressions, which is really the best strategy here, and see which ones can be simplified and would end up giving you a divided by c. Now, there should only be one of these that matches. So let's look at a. We have a times b divided by c times b. So how do we simplify this? Well, we have a continuous multiplication link on the numerator and on the denominator. And this is important because this is the only way in which we're allowed to essentially cancel things, numerator, denominator, elements that appear both on the numerator and on the denominator of a fraction. If we didn't have a continuous multiplication link, we couldn't cancel anything. In this case, though, there is a continuous multiplication link in both the numerator and the denominator. So we see that b appears both on the numerator and the denominator. And they both have the same power, the power 1. So the b's will cancel to a 1, which means that we're left with a divided by c, which is exactly what they wanted us to match. So we know that a is a match. Now let's just continue to explore the other ones and see why the other ones wouldn't work. If we look at choice b, what happens with choice b is this. If we write a times a divided by c times c, well, a times a can be written as a squared and c times c is c squared. That's it. You can't do anything else. That's not equivalent to a over c, so choice b is incorrect. Choice c, you have a times c divided by c times a. Something interesting happens here. A times c, well, again, continuous multiplication link, both numerator and denominator, so that means that we can cancel things. Rearranging, it's very simple to see that you essentially have the same thing on the numerator as you do on the denominator, which means that you're going to end up with the value 1. Whenever you divide two equal amounts, and again, because they're telling us that these are positive integers, in other words, 0 is not to be considered, we can cancel this to a 1, and 1 is not a over c. So clearly, c doesn't work. Then d and e, because both of these, let's look at d, you have a minus b divided by c minus b, we don't have a continuous multiplication link, neither in the numerator nor on the denominator. But really, as long as one of those, the numerator or the denominator, doesn't have a continuous multiplication link, then we need to stop. We can't really cancel elements. So it would be incorrect to think that you could cancel these b's over here. That would be wrong. No, you can't do anything to this. This is really the best you can do with this expression, and that's clearly not a over c. So d doesn't work. For the same reason, no continuous multiplication link on the numerator, and to boot, neither on the denominator. So choice c stays as a plus b divided by c plus b. You can't simplify it. So it's not equal to a over c. If you think that you can cancel the b's there, no, again, no continuous multiplication link. That's why d and e do not work out. Choice A was the right one. Now, of course, it should have been the first one you tested, and as soon as you realized that A was correct, you didn't have to continue testing the other ones. But I just wanted, for problem 22, it reads, what is the slope-intercept form of 6x minus 2y minus 4 equals 0? And you see 5 choices here. And just remember that, slope-intercept form means that you've solved the linear equation for y. In other words, y equals something. And you can see from the choices that that's what happened here. We solve for y. So essentially, this is an algebra problem where you're solving this expression for y. Now, something interesting, should be noted here. Typically, students want to have the y on the left side. They feel more comfortable with that. And you can see the choices have the y on the left side. But it's not always ideal to do that. In this case, you can see that if we're solving for y, we want to take this term, the subtracting 2y, and we want to send it to the right side, adding It'll save us a lot of problems. Look what happens when I add two y's to both sides. So on the left side, we end up with 6x minus 2y minus 4 plus 2y. Well, subtract 2y and add 2y, you're essentially canceling that. You're left with 6x minus 4. On the right side, you end up with 0 plus 2y, and that simply means 2y. Now, the last step would be to divide both sides by 2 because you're isolating the y, and the y is currently being multiplied by 2. So dividing the entire left side and the entire right side. Remember, equations are like scale balances, the type that when you add, say, a weight to one side, if you have the same amount on the other, it'll be balanced and equal. Okay, that's how equations should be treated. So if I divide one side by 2, I need to divide the other side by 2 as well. So when I do that, these two on the right side, these 2's will cancel because we have a continuous multiplication link on the numerator. So we're allowed to do that. So there you go. We have our y isolated. And then on the left side, we should be able to simplify this. 6x minus 4 divided by 2. Well, the 2 is dividing all of the terms on the numerator. So 6x divided by 2 is 3x, and then minus, minus, and 4 divided by 2 is 2. So we're left with this expression. Now, if you're thinking, well, I have the y on the right side, I'm stuck, well, you can easily flip this. 3x minus 2 is equal to y. It means that y is equal to 3x minus 2. Think about it. If you have, say, 5 is equal to x, you can easily write x is equal to 5. The order in which you present these items doesn't really change the fact that they're equal to each other. So now we can go to our choices here and check and realize that the correct answer is H, y equals 3x minus 2. Now, notice what happens if you make, in my point of view, if you make the mistake of trying to keep the y on the left side. You're just going to have a little bit more of a struggle solving for y. Watch. 6x minus 2y minus 4 is equal to 0. A lot of students will want to keep the y on the left side because they think that it has to be that way, and it's false. And you do whatever is easiest. But let's say you wanted to keep it there. Well, that means you want to isolate the y term, so you start probably by sending this positive 6x to the other side. You achieve that by subtracting 6x from both sides of the equation. So 6x minus 2y minus 4 minus 6x, these cancel to 0. And careful with this one. 0 minus 2y minus 4 means that this is negative 2y minus 4. And then 0 minus 6x is negative 6x. So you see, you're going to have to deal with the negative signs, and it's easy to make a mistake with that. You can now probably appreciate why the other route was much easier. You would then probably want to add 4 to both sides. So that way you end up with negative 2y on the left because the subtracting 4 and the adding 4 cancel each other out. And then this is going to be equal to negative 6x plus 4. And then as a last step, and this is where you have to be careful, you would need to divide both sides by negative 2 because you want to get rid of negative 2 over here. You want to solve for y. If you just divide by positive 2, you would end up with a negative y on the left side. You're not solving for negative y, you're solving for positive y. So you need to divide both sides by negative 2. Now, it's true that negative 2y over negative 2 does cancel out these negative 2's to a positive y, but then just be careful with the right side here. Negative 6x plus 4, everything divided by negative 2, well, you can look at it in steps. Negative 6x divided by negative 2, you got a positive 3x. And then an adding 4 divided by a negative 2, well, because you have a positive divided by a negative, you're going to end up with a negative. Add a negative, you subtract, and then 4 divided by 2 is 2. But look how much more complicated it was to go down that route. And again, you could have made a lot of mistakes along the way with those signs. So sometimes it pays off to not have the variable you're solving for on the left side. Maybe easier to just... For problem 23, which of the following is a solution to the equation x squared plus 25x equals 0? And they give us 5 choices there. We could solve it using 2 methods. The first method is taking this equation and solving for x. Now, because we have a quadratic here, the variable raised to the second power, the variable we're trying to solve for, we need to know the right method to use. One of the things you could do here is, because x is being squared, you know it ultimately means x times x, and then you have plus 25x is equal to 0. I'm writing it like this because for some students, it's easier to visualize what I'm going to do next. You see, you have two terms. This is the first term, this is the second term, and both of those terms contain at least one x. So I'm going to factor out an x. In other words, I'm going to take out an x from the first term, and I'm going to take an x out from the second term. If I do that, I'm left with one x, a single x, on the first term, plus, and then just a 25. And they should be equal to 0. Now, go backwards. If you distribute x times x, you get xx, or x squared back. And then if you multiply x times an adding 25, you get 25x. You get that second term back. So this works. Now, why are we doing this? Because notice that you have two elements here multiplying, the x and then the x plus 25. If you think of the following property of multiplication, that anything times 0 is equal to 0, that opens up the following door. If you need two things multiplying to be equal to 0, well, the only way to make this happen is if the first thing, or the first part here, in other words, x, if this is equal to 0, there you go. The first solution to the equation. If you plug in 0 to x, for x in the original expression here, you're going to get 0 equals 0, which is going to be true. 0 squared is 0, plus 25 times 0 is 0, 0 plus 0 is 0, 0 equals 0. So we found one of the answers, but it's not one of the answers shown. So we need to find the other one. Where do we get the other one from? Well, from this second part right here. We can set it to 0. We can say, look, if I can make x plus 25 be 0, then I know it'll also work. So solving for x here means subtracting 25 from both sides, which leads to the correct answer, x is equal to negative 25. So this is called the first solution, x of index 1 is equal to 0. This is called the second solution, x of index 2 is equal to negative 25. Quadratics, equations that have a variable raised to the second power, will always have two solutions. So they may be equal, but it'll have two solutions potentially. Anyways, in this case, x of index 2, or the solution we wanted, is negative 25, which is choice E. Now, if you think that this is too complicated, there's another method that you can use. And remember, this is always available when you're taking the ACT exam. Use the choices given. Now, it's going to be just a little bit of a headache there, but what you would need to do is, if you're trying to see which of these values makes the equation be true, plug them in for x. So plug in, say, the first one, 50 squared plus 25 times 50, and then see if this equals 0. Now, you can clearly see that it's not going to happen because you're going to get a positive, another positive, adding, impossible for these to cancel each other out. So plugging in a positive is really not going to work, so that eliminates A, B, and C. So really, after the first one, you should realize that B and C would never work either, so you're left with choice D and choice E as the other options. And if you plug in negative 5, you would need to just be careful how you plug that into the calculator. Remember, you need parentheses and then the squaring so that the calculator does give you the right answer for this of positive 25. Then 25 times negative 5, of course, it's going to be a negative, so you're going to end up subtracting, but it's not going to be 25, so this is not going to be equal to 0 either. So choice D, for that reason, would be wrong. And then plugging in E, negative 25, you would be able to see that that would give you the correct answer. Negative 25 squared plus 25 times negative 25 will be equal to 0, because negative 25 squared, that's going to be a positive number, and negative 25 squared simply means 25 times 25. Now, 25 times negative 25, this is going to give you a negative. Add a negative, you're going to end up subtracting. You're going to end up subtracting 25 times 25. So your you have a positive 25 times 25, and subtracting that same amount, it'll cancel to 0. For problem 24, it reads, for the right triangle ABC shown below, what is tangent of B? So just remember what the trig functions are defined as. Sine of an angle is equal to the opposite side of the angle divided by the hypotenuse. Now, cosine of an angle is equal to the adjacent side to the angle divided by the hypotenuse. And finally, the tangent of the angle is equal to the opposite side divided by the adjacent side to the angle. So that's important for you to know, that this is with respect to whatever angle you're talking about. So in this case, they're talking about angle B because they ask for tangent of B. So it's this angle right here. In other words, this one. Now, if we look at the definition of tangent, it's equal to the opposite side to the angle divided by the adjacent side. So what's the opposite side to the angle? It's C. So side C divided by the adjacent side. Adjacent side to the angle is, of course, to this angle, is A. So C over A. And that means that J is correct. So this prompt does require you to know the trig functions, sine, cosine, and tangent. And you should always memorize this little table right here. And just know that the angle refers to whatever angle you're talking about. So for example, if instead of using angle B, we talked about angle A, look what happens. Tangent of A, well, if it's this angle now that we're using, opposite to A is side A. And then adjacent to A would be C. So the answer would have been different. That's why it's important for you to know that the trig functions, you need to know which angle you're using, if in this case, if it's A or if it's B, so that you can correctly pinpoint which one is the opposite and which one is the adjacent.